Concussions. In this video, we will be answering the question, how do concussions impact the cognitive abilities? We will be analyzing this question by looking at the physical, chemical, and biological aspects behind concussions.
Before we look at these properties, we must understand what a concussion is. A concussion, also known as traumatic brain injury, is a head injury usually caused by an accidental or intentional blow to the head.
Concussions are most common in sports. For example, this drawing illustrates someone getting hit in the head by a baseball, which results in the person becoming concussed. Take note that the bump on the head is only to emphasize the force by which the person was hit. It is not the actual concussion.
Now let's look at the physics behind concussions. This is Johnny. Johnny just got hit in the head by a soccer ball. Inside the skull, the brain has room to move. When Johnny gets hit in the back of the head, the force behind the soccer ball causes the brain to compress into the skull. The brain is then compressed again against the other side of the skull as it rebounds. Kinematics can be used to explain the force behind concussions. The definition of kinematics is pure motion without any other forces acting upon it. Like we said before, the deceleration, which is a sudden decrease in motion after contact, along with the acceleration, causes the brain to jolt, which can be calculated using kinematics. This formula, which is the acceleration or the deceleration, equals the initial velocity subtracted from the final velocity, which is then divided by 2, multiplied by the distance traveled, multiplied by gravity, which is 9.81 meters per second squared. Newton's 3 laws of motion can also be used to explain the physics of concussions. The first law is that unless an unbalanced force is applied, an object at rest stays at rest, and an object in motion stays in motion, with the same speed and direction. The brain is an example of this. Unless an outside force is applied, the brain stays within its position in the skull. The second law is the law of acceleration. A force applied to an object causes an acceleration based on the mass of the object. This explains what occurs after the brain comes into contact with the skull. A formula to determine the force exerted on the brain is mass multiplied by acceleration. The third law explains how in a concussion, the force applied to the skull is met with an opposite reaction force on the brain from the skull.
During a concussion, nerve tissue can stretch and tear. This can cause the balance of ions and different chemicals in the brain to change. The nerve tissue is a major factor in concussions. Axons are located in nerve tissue, which are one of the main components for the brain's communication system. When the nerve tissues are torn, messages going through the axons have a very difficult time getting through. For the message to get through, action potential must take place. Action potential, which are nerve impulses, occur when a neuron sends a message down an axon. The action potential activates the calcium and potassium channels. The potassium rushes out of the neurons and the calcium diffuses into them. This can cause a clog in the neuron's mitochondria. After this, neurotransmitters are released into the synapse and then bind to receptors. This process causes sodium channels to open and an action potential is sent on through the sodium channels. This is the message being sent through the axon. When a concussion occurs and nerve tissues are stretched or torn, the axons are torn, which causes the messages to either slow down or not send at all. This causes the person to have delayed reactions, loss of focus, or no concentration at all.
Concussions can cause people to experience post-concussional symptoms such as headaches, dizziness, fatigue, impaired focus, and an increased sensitivity to light and sound. Rapid stretching from concussions also causes axons to swell, compromising the ability of the cells to send signals. Too much swelling and the connections between cells can be permanently lost. The effects of concussions on brain cells are mostly temporary, but brain recovery is only possible with both mental and physical rest. This allows brain cells to restore their normal internal chemistry.